For this video lecture, I'm going to talk about serverless computing. Sometimes they just call it serverless. For the overview, serverless computing is a cloud-native development model that allows developers to build and run applications without having to manage servers. There are still servers in serverless computing, but they are abstracted away from app development. A cloud provider handles the routine work of provisioning, maintaining, and scaling the server's infrastructure. Developers can simply package their code in containers for deployment. So the dev team or the developers need not worry about the server because when you subscribe to a serverless computing, the server becomes an abstraction, and all they have to worry about is about their codes and package it and place it in the container for deployment. Once deployed, serverless apps respond to demand and automatically scale up and down as needed. Serverless offerings from public cloud providers are usually metered on demand through an event-driven execution model. As a result, when a serverless function is sitting idle, it doesn't cost anything. So uh, customers will only pay when the code is running. Otherwise, that's in serverless computing. Otherwise, you will not be paying anything. That's the model. So overview of serverless architecture. Serverless computing differs from other cloud computing models in that the cloud providers is responsible for managing both the cloud infrastructure and the scaling of apps. Serverless apps are deployed in containers that automatically launch launch on demand when called. Under a standard infrastructure as a service or IaaS cloud computing model, users pre-purchase units of capacity, meaning you pay a public cloud provider for always-on server components to run your apps. It's the user's responsibility to scale up server capacity during times of high demand and to scale down when that capacity is no longer needed. The cloud infrastructure necessary to run an app is active even when the app isn't being used. So this is actually what we have most of the time right now. When you buy, say, services from AWS, you are actually most most of the using right now is the IaaS model, cloud computing model. You buy for a certain capacity and then or resources, and then you pay for that. It's just like in the cell phone. When you are paying for when you have a line phone, it means that you are like using it for infrastructure as a service because you have a fixed price. Even if you're not using your phone, say you only use it once, but you will still pay for it monthly. Or internet subscription, house subscription, like you have bees. So that's also an infrastructure as a service model. But serverless computing model is a different model. You only use it. No, no, no. You only pay it when you use it. So similar to when you have a prepaid, diba, you load and then the balance will only be deducted every time you use your phone, when you use it for call or you use it to send messages. So if you're not going to use it, your balance, whatever you have loaded there, will still remain the same. So that's what serverless architecture is. Still on the overview of serverless architecture. With serverless architecture, by contrast, apps are launched only as needed when an event triggers app code to run. The public cloud provider dynamically allocates resources for that code. The users the users stop paying when the code finishes executing. In addition to the cost and efficiency benefits, serverless frees developers from routine and menial tasks associated with app scaling and server provisioning. With serverless, routine tasks such as managing the operating system and file system, security patches, load balancing, capacity management, scaling, logging, and monitoring are all offloaded to a cloud service provider. It's possible to build an entirely serverless app or an app composed of partially serverless and partially traditional microservices components. So, what's the cloud provider's role in services computing? Under a serverless model, a cloud provider runs physical servers and dynamically allocates their resources on behalf of users who can deploy code straight into production. Serverless computing offerings typically fall into two groups: back as a service or BAS, and function as a service or FAAS. BAS or backend as a service gives developers access to a variety of third-party services and apps. For instance, a cloud provider may offer authentication services, extra encryption, cloud accessible databases, and high fidelity usage data. With BAS, serverless functions are usually called through application programming interfaces or APIs. So BAS, you subscribe to APIs, and if you just use existing APIs to build on a certain app that you'd like to develop, BAS for you. More commonly, when developers refer to serverless, they're talking about a FAAS model. Under FAAS, developers still write custom server-side logic, but it's run in containers fully managed by a cloud services provider. The major public cloud providers have one or more FAAS offerings. So those we already know actually most of these cloud providers. Anyway, they include Amazon Web Services (AWS). So the AWS Lambda is a serverless computing. That's their that's what they that's the 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 department, probably the AWS Lambda. Microsoft Azure also has one, and it's under the Azure functions. And then Google Cloud with multiple offerings, and IBM Cloud with IBM Cloud functions. And these are just some of them. Some organizations choose to operate their own FAAS environments using open source serverless platforms, including Red Hat OpenShift Serverless, which is built on native project for Kubernetes. So what's function as a service or FAAS? So function as a service is an event-driven computing execution model where developers write logic that is deployed in containers fully managed by a platform, then executed on demand. In contrast to BAS, FAAS affords a greater degree of control to the developers who create custom apps rather than relying on library of pre-written services or APIs. Code is deployed into containers that are managed by a cloud provider. Specifically, these containers are stateless, making data integration simpler; ephemeral, allowing them to be run for a very short time; event trigger, so they can run automatically when needed; fully managed by a cloud provider, so that you only pay for what is needed, not always on apps and servers. Then, here are some of the pros and cons of serverless computing. For the pros, serverless computing can increase developer productivity and reduce operational costs by offloading the routine tasks of provisioning and managing servers. Developers have more time to focus on their apps. Next, serverless helps enable DevOps adoption by reducing the need for developers to explicitly describe the infrastructure they need operations to provision for them. It's possible to streamline app development even further by incorporating entire components from third-party BaaS offerings. Then, operational costs are reduced in a serverless model because you can pay for cloud-based compute time as it's needed, as opposed to running and managing your own servers all the time. For the cons, not running your own server or controlling your own server-side logic can have drawbacks. Cloud providers may have strict constraints on how their components can be interacted with, in turn affecting how flexible and customized your own system can be. In the case of BaaS environments, developers may be beholden to services whose code is outside their control. Diba? If you're using API, you cannot just open APIs and make it your own. It's very difficult, even if you can. So normally you just API SCTs. Just like in assembly, when you have assembly, you use a certain call. You cannot just change the code because it's already there, like interrupt calls. So just similar to APIs. Ceding control of this aspect of your IT stack also opens you up to vendor locked in. Deciding to change providers will also likely come with the cost of upgrading your system to adhere to the new vendor specifications. And evolution of serverless computing. So the concept of serverless architecture and FaaS have grown hand in hand. With the popularity of containers and on-demand cloud offerings, a 451 research report done in cooperation with Red Hat traced the evolution of serverless into three phases. The 1.0 phase of serverless came with limitations that made it less than ideal for general computing. Serverless 1.0 is characterized by HTTP and few other sources, functions only, limited execution time 5 to 10 minutes, no or orchestration, limited local development experience. Still under evolution of serverless computing. The advent of Kubernetes ushered in the serverless 1.5 era, where many serverless frameworks started to autoscale containers. Serverless 1.5 is characterized by native, Kubernetes-based autoscaling, microservices and functions, easy to debug and test locally, polyglot and portable. Still under evolution of serverless computing. Today, the serverless 2.0 era is emerging with the addition of integration and state. Providers have started adding the missing parts to make serverless suitable for general purpose business workloads. Serverless 2.0 is characterized by basic state handling, use of enterprise integration patterns, advanced messaging capabilities blended with the enterprise PaaS, enterprise-ready event sources, state and integration. And here are some examples of serverless computing or companies or apps that uses serverless computing services. So the growing popularity of cloud computing and microservices combined with the demand for greater innovation and agility without increasing costs has contributed significantly to the prevalence of serverless applications. Notable use cases include, first one is Slack. Serverless is ideal for independent task-based applications such as chatbots and can save on operational costs since billing is based on actual number of requests. Slack, a popular cloud-based business communication platform, uses a serverless application called Marbot to send notification from Amazon Web Services to DevOps team through Slack. So this is Slack. Next is HomeAway. So this is an app. So reducing development time and server cost while simplifying the build process are goals that universally appeal to business teams and IT teams. HomeAway relied on Google Cloud Functions to develop an app that allowed users to search and comment on the recommendations of travelers in real time in areas without an internet connections. The cloud services available through Cloud, Firestore, and Cloud Function made it possible to set up the infrastructure within minutes and deploy the app within 6 weeks with just one full-time developer. Then you have the green queue. Garbage pickup and disposal is an industry that may not seem to require innovative technology, but GreenQ took a sophisticated approach to streamlining and improving waste management by using IBM OpenWhisk to create an IoT platform that uses hardware installed on garbage trucks to collect key metrics such as pickup time, location, and load weight. The auto-scaling available through serverless were particularly valuable due to the fluctuation of infrastructure demands based on the number of customers and the trucks at any given time. So because of that, GreenQ uses serverless computing. I just hope that we also have this kind of technology here. And then HomeAway. Wait, I pressed the wrong button. I think this is the last one, Coca-Cola. Soft drinks giant Coca-Cola's enthusiastically embraced serverless after its implementation in vending machines resulted in significant savings. So it uses serverless computing for its vending machines. Whenever a beverages is purchased, the gateway makes a call to the AWS API gateway and triggers an AWS Lambda function to complete the transaction. Since vending machines must communicate with the headquarters for inventory and marketing purposes, the ability to pay per request rather than operating at full capacity had substantial impacts on reducing cost. So these are some of the examples and cases where a company or an app uses serverless computing. And then drawbacks. This is in addition to the pros and cons discussed earlier, specifically the cons. So response time. Serverless computing is an paralleled framework when it comes to the rapid development of application, but how well does the framework perform? So we've seen an example that if you want to develop an app, you can use the serverless computing and you can build an app in in how many months. A complicated app, like in our example, only one developer, and then it was able to build up in 6 months. But it will take some heat, response latency. So one drawback of switching to serverless computing may be response latency. Response latency is the time between when a request is stimulated and when a program reacts. In the cloud, serverless computing is not continually running, it gets powered down between requests. As a result, having to start from dormant serverless code can cause response latency. It can take as long as several seconds to spin up and process code. Depending on your specific use case, especially if timing is critical, this could be a point against serverless. Another drawback is limitations. Third party vendors restrict resource limits, which means serverless computing is not ideal for high computing operations. Even if they were no such limits, certain applications would not be cost effective from a third party vendor. As any cloud service, you'll also want to be aware of vendor lock in and what you'll need to do in order to switch serverless providers. Security. Like anything in technology, you must consider the security factor when it comes to serverless computing. So, responsibility of security falls on the servicing company, not the consumer. There is a larger attack plane with multiple entry points into the server. Customers sometimes feel reassured shifting security demands to the company that owns the server. But large servers with multiple entry points may be more vulnerable, and if an attack does happen, consumers are powerless against it, relying instead on the provider to disclose, remediate, and recover. Then you have debugging. It is generally more challenging to debug serverless code. Devs also have a more challenging time spotting problems as the code doesn't lend itself to digging in for a detailed review of issues or code smells. Understanding, anticipating, and preparing for these challenges will be critical in meeting the end users' need and helping your organization gain a competitive edge with serverless computing. So here are some of the sources that I use for this presentation. Uh, Serverless computing is a emerging technology, and just like any other emerging technology, this is not something that's cure all or can be used by uh, whenever you might want to deploy an app. It's not like that. It will still depend on your needs. We've seen that it works well when you are going to use it for a small system or uh, system, but for more complex system or system that requires some big data, then cloud serverless computing might not be the right technology. So it will still depend, but for the small systems, and you need rapid development, then cloud, this particular technology, which is serverless computing, might be for you. So with that, I'd like to thank you, and let me end my report here.